All right. Good morning, everyone. Yeah, welcome to Biochemistry, Metabolism of drugs and xenobiotics. In this course, we are going to discuss these basic outlines. I was in the class on Tuesday, Wednesday, that was yesterday. And unfortunately, I only met one person. So you have an option whether to continue with the class or to rather have something like a recording and share with the class. So luckily enough, the person is wanted a recording so that even those that are not yet school can follow the class without missing any part of it. So I decided to do that. In this course, we are going to basically discuss the metabolism of xenobiotics. While doing that, considering the outlines, we're going to discuss introduction, define what is xenobiotics there. And then we talked about what are the sources of these xenobiotics. How do these xenobiotics, when they come in contact with the body, get into the body before they finally reach the points where the body metabolizes them? What are the processes or mechanisms involved in the excretion of these xenobiotics? We will also see some metabolism of some drugs, some selected drugs, ethanol, talked about British anti-parasites, and then we're going to have some tutorial questions. I will give the tutorial questions. Then a revision class. Then after revision class, we're going to have a tests. So yesterday in the class, I was able to put the outline on board. So the outline includes the class with one, which will basically with this class. In this class, I'll be giving the introduction down to phase one metabolism. While in next week, we will talk basically about phase two metabolism and some examples. With three, we are going to talk about factors affecting drug metabolism. With four, then we'll discuss about basically the revision. That's if we were able to meet up with the schedules, because in between these things, I didn't actually have the outlines. Until when I opened this, I discovered that the outline is not here. I didn't break it down. So I should have broken it down, but the ones I gave in the class was a breakdown. By the way, we'll be discussing each and every part of the stages, so that while discussing each stage, you will know how broad this component are. So the first component include the pharmacokinetics and some aspect of the biotransformation. The second component include the biotransformation, and then some aspect of metabolism of some drugs. Then the next include the British anti-parasites, the factors affecting drug metabolism. And then the last part, which will basically be revision. If we were able to meet up with this, I want to have 1 month so that we can finish with all the content. And then we're going to have a revision. After revision, the 5th week, instead is going to be a test. So you've already fixed the test for it, and I would want the class from the timetable. The class supposed to be on Tuesday. I would have loved it if the class can be shifted to Thursday. So the class will discuss with the class rep to see the possibility of shifting the class to Thursday, so that I will have the class on Thursday. So if we look at it in this, then this week will be the first week. And then subsequently, we are going to have 3 weeks. Then we're going to have the revision class and then the test. So you can start counting. As once it is time, we are able to meet up with the time, then we have to do as we suggested. So, xenobiotics. What are these xenobiotics? Xenobiotics from the Greek word means xenos, which means strengthen, foreign, or non, or endogenous, something that is not known by the body. Remember, in the previous classes, mostly the metabolism classes, we discussed about metabolism of biomolecules. And these biomolecules, even though you discuss digestion, how these biomolecules comes into the body. But because the body knows these things, the body can also produce them. We are talking about carbohydrate, because the body can produce carbohydrate. We are talking about proteins, the body can produce proteins. We are talking about lipids, the body can produce fats and lipids. So all these ones are endogenous, they are classified under endogenous compounds. These are compounds that are known by the body, while we have exogenous compounds from the other side that are not known by the body. So now when you take food undergo digestion and then absorption, once they get into the body already know what it is. And it's know what it is used for. So the metabolic pathway specific for this will be carried out, and then they will be utilized based on what they are meant to be used for. But we wonder, with respect to the current substance that the body doesn't know. Yes, these classes of compounds are also identified, or I don't know this people. Therefore, there is a particular pathway that these things will have to do. We are going to see in biotransformation why those pathways, after these substances get into the body, why they are directed to a particular pathway, and what happened, or why are they even directed to their pathway? What happened after the metabolism? We want to see that. Okay, so what are the sources of these xenobiotics? These xenobiotics mostly foreign substances. So drugs, they are from pharmaceutical industries. There's the one isolated and the synthetic. The body does not know. So when you take them, the body doesn't know them. You can have a chemical substances, maybe some synthetic compounds produced from chemical industries, plastic, pesticides, pigments, and you can also have food additives that comes from food industries. So in the process of eating food, we eat foods that contain some preservatives. Some preservatives are not known by the body, so they will have to pass through this pathway so that the body can metabolize them to ensure that no damage is being done to the body. Okay, So while discussing the xenobiotics, we will have to talk about pharmacodynamics and pharmacokinetics. You pardon me for the use of the word pharmaco, which basically refer to drugs. And so it's supposed to be the dynamics of these xenobiotics and the kinetics of the xenobiotics when they get passed into the body. But being the fact that our discussion include the drugs themselves, so you pardon me by using the terminologies. So in pharmacodynamics, they deal with the study of the biochemical and physiological effect of xenobiotics on the system. So when these chemical substances enter into the body, they may have some bioactivity or they may have some toxicity effects. This bioactivity or toxicity effects is basically the dynamics of these compounds. What are the effects of these compounds on the biochemical or physiological phenomena of mechanism? What do they cause? They can trigger a particular pathway, they can trigger a particular response, they can trigger epistemological responses. So this aspect is classified as pharmacodynamics, which basically does not form part of what we will be discussing in this class. Our discussion will be basically on how does the body handle these substances? How does the body metabolize them? Just like when you are talking about carbohydrate metabolism, you say that, okay, carbohydrate is taken, broken down to glucose absorbed out of the body, break down the glucose and produce energy. Then to produce energy, you stop there. You don't talk about where is the energy being used for. Even though along the process, if it means to mention that ATP is used in the metabolism of glucose, for example, of course you will mention that the attempt is to tell how is this glucose being metabolized, either through catabolic pathway or through anabolic pathway. So gluconeogenesis or glycolysis. They are similar to any other molecules you discussed in the class. So in the previous classes. So in this case also, we will see when these things enter the body, what happens to these substances, or how does the body handle these substances is what we are interested in. So we may be talking about some drugs. We may not pay much attention to how this drug causes its own effect. Rather, our concern is how does the body handle the drug. We may, in a ways, say one or two things that relate to the function of the drug, that means the effect of the drug on the body. But the aim is to discuss how does the body handle that substance. Maybe the process of handling leads to manifestation of the effect of the drug. Okay, so this is basically about the pharmacokinetics and pharmacodynamics. So in pharmacokinetics, we say the pharmacokinetics deal with the effect of the body on the drug itself. So, and it's include absorption, distribution, metabolism, and excretion. It covers all this, which we will be discussing the effects of the xenobiotics on the basis of absorption, distribution in the body, and how does these xenobiotics get in contact with the body depending on the route of contact, then absorption, how is it absorbed into the body, getting into the body, then how does the body, or how is it distributed to various organs in the body, and how does the body metabolize them? What are the organs that are involved in the metabolism of these xenobiotics? And what are the key organs also involved in the excretion of these substances, which will basically form the basis of our discussion. We will give examples and then see some specific conditions and some factors. And then finally, Now, talking about absorption of xenobiotics. Now, depending on the route of exposure, it could be oral. You can come in contact with, for example, a pollutant through oral ingestion. Maybe you take contaminated water with a pollutant, with heavy metals and some chemicals, or maybe you eat a food that contains these chemical substances. So there is, we said, oral ingestion. We take them into where they pass through GIT, and then we get into the body through intestinal absorption. Or you can have an exposure through contact, skin contact, where they pass through the skin. Or you can inhale when it is in the gaseous form, where it goes into the lungs and then get absorbed. So these are the basic, or you can even have, which is the everywhere, you can even have a direct, the chemical can get into the body direct, maybe through intravenous, intramuscular, but in most cases, this one when we refer to drugs. Okay, now let's look at the intestinal absorption. When you take a substance, a drug, let's take a drug. First of all, to pass through the GI and get into the intestine. The area of the small intestine, this is where the absorption takes place. Now, the absorption is possible when it's able to pass through the membrane lining of the intestinal mucosal cells. And we have already known the process of the movement of substance in and out of the membrane. How is it controlled? So the same thing applied here also. Number one, you can have molecules. If those molecules are lipophilic in nature, they can easily get themselves into them by what? By just, light to dissolve light. So they just dissolve on the membrane and get themselves through the bilayer, then to the other side of the membrane. It's as easy as that. So more lipophilic molecule can just diffuse or transverse the membrane. They can bind themselves inside the internal sites. That's number one. Number two, you can have the very small molecules. So it doesn't matter if it is the size of the molecule is very small. So it could be lipophilic or hydrophilic. But due to the size, they can easily diffuse in through a simple diffusion process. So through simple diffusion, these substances can go into the body and they find themselves inside the cells.